specialty producers. Thank you for joining us to learn about drip irrigation with our guest, Dr. Jia. This segment has been funded through the Conservation Collaboration Agreement NR 226740XXXC008 between the National Resource Conservation Service and the South Dakota Specialty Producers Association to promote sustainable agriculture practices and environmental stewardship. Its contents are solely the responsibility of its authors and do not necessarily reflect the official views of the USDA or the NRCS. So I would like to kick off the program by introducing our guest, Dr. Jia from the NDSU, Professor of Agriculture, Biosystems Engineering, and Director of the North Dakota Water Resource Research. During this hour, she will be presenting the benefits about using a drip irrigation system in specialty productions. I will hand it over to you.
Thank you. Let me share my slides. Can you see my slides?
Yes, I can.
Okay. All right. Well, thank you. My name is Xinhua Jia. I'm a professor in the Department of Agriculture and Biosystems Engineering. I'm also the director for North Dakota Water Resources Research Institute. And today it's my pleasure to talk about drip irrigation for vegetable crops or specialty crops. So when we talk about irrigation, so what is irrigation? Irrigation is the supply of water to crops by artificial means, whether it's through gravity or pressurized irrigation. So this is a table showing where the irrigation is located. As you can see, worldwide, that for Asia, 39% of land, cropland is irrigated, where for US, 14% of cropland are irrigated. However, there's a 14% of land with irrigation. They provided a much higher economic value compared to the land that without irrigation. And this is a map showing where the irrigation is distributed in US. On the left side, as you can see that each one of the blue dots represent 10,000 acres of irrigated land. As you can see that there's much dense blue dots in Nebraska and then, in California. They're not too much in North Dakota and South Dakota. And the table here also showed that Nebraska is leading the US in the percent of the land with irrigation, followed
Doctor?
by, yes?
Doctor, our slides are not moving.
Oh, okay. Apologize. Okay. Settings. Apologize for this. Let me reshare. Can you see my screen now?
I can see your screen, but it's still on the cover page.
Oh, okay. I apologize.
There we go.
Okay. Well, this is not slides show, so I think, apologize. I wasted some time. Okay, can you see the slideshow?
Yes. Oh,
Okay,
yep. Now
great.
now they're moving it.
Okay, great. Yeah. Apologize for this. So this is the percentage of the land with irrigation, As you can see that America has 14% of the land. And then move forward, as you can see that the leading state with irrigation is Nebraska and California in the US. And then another figure I want to show you that even though we're not the leading states, but looking at this figure, the blue dots showed there's a 5,000 acre irrigation that's gained from 1997 to 2017. And as you can see that most of the gain is in the eastern part of the states. And this is for the 17 states, including South Dakota and North Dakota, and farmland that's with irrigation. And the change of the irrigation or the gain of the irrigation is really in the pressurized irrigation, where the orange bar is located. So now come back to irrigation. As we mentioned, that's the artificial supply of water to the crop. So with irrigation, we can definitely have a stabilized farm income, increased crop yield and quality. And some area, for us, we do frost protection, where in the southern part, they may do a crop cooling. And overall is efficiency of resource use, because with irrigation, the water is used much efficiently. And then, of course, there's drawbacks with irrigation. First, the cost of this equipment is very high. And yes, you can get some cost share from NRCS. And also the management operation can be very costly, especially you use the pressurized irrigation. You need to pay the pumping bill, every month. And also there's a potential adverse environment impact, especially for North Dakota and South Dakota, the eastern part. Our soil have a very high soil salinity. So when we do irrigation, we got to be very careful, because we don't want to over irrigate or under irrigate, so that we can cause the secondary soil salinity problems for our land. And also a lot of our field has a hard pan on the subsurface layer. Sometimes it's 2 feet below surface, sometimes maybe a 2 meter below surface. So you need to know where's your hard pan. Otherwise, maybe you will over irrigate and cause waterlogging of the soil. So there's things we get to pay attention, but of course the benefit is much better or higher than the drawbacks. So if we decide, yes, we want to do irrigation, then you have to determine that when to irrigate and how much to irrigate. And that's the question that people always ask. Well, when people ask me, I would say, well, it really depends on, the principles, whether it's based on the crop, crop stress indicators, or climate conditions, or your soil moisture status. So when to irrigate can use plant, soil, or you can estimate that based on the water balance or even energy balance, or how much to irrigate based on the soil water measurements or the water balance approaches. So there are a lot of calculations go behind the doors if you are, the professionals. But if you are farmers, to be safe, there are some general rules, like for muscle crops in the eastern part of the state. The highest water that's demanded for irrigation is about 0.3 inches per day. That's during the hot summer, around July 4th. And then that can be irrigated, if you irrigate more a large amount, you probably can irrigate every 3 days. So that means it's about 1 inch per day. But then it will be like, what is your soil? If you have a sandy soil, your sandy soil cannot hold 1 inch of water. So there's something that we will cover that in a moment. So this figure is from my colleague, Dr. Dean Steele, that we have a full soil moisture content we describe to really figure out that how to irrigate and when to irrigate. So if you have a soil and you have the saturation when all the soil pores are filled water, and the field capacity is when the water in the large pores that's drained out through gravity. And permanent waiting point is the lowest point where your crop can get any water from your soil. And then, of course, you can completely dry the soil with the oven. And so if a field capacity means 100% of the soil moisture deficit, there's no need for irrigation. Well, 0% is the permanent waiting point. And now we also introduce the management allowable depletion. And this is a term that on how you want to manage water. You don't want to wait on your soil when it is completely dried to the permanent waiting point. So for field crops like a corn, maybe 50 or 60% of the MAD is fine. Where for vegetable crops, maybe 10%, 20, or even 30% of what you normally use. So that means, the red bar means this is the entire bucket of water that you can manage for your crop. This is the available soil moisture. And then if you have a 60% of MAD for corn, and then this is a green bar. So when it's a field capacity, you stop irrigation. When it's 60% MAD, you start your irrigation. So, and then the amount of water between field capacity and 60% of MAD, plus, your root zone is the amount of water you need to use for irrigation, supply. So, as we mentioned, we talk about this water balance. This is the famous irrigation scheduling by checkbook methods where North Dakota, South Dakota, Minnesota, even in a lot of the other states were using. So to simplify that, we want to know how much we need to irrigate today. We need to know the soil water deficit from yesterday. We need to know the evapotranspiration or crop water demand from yesterday, and also the effective precipitation. So it's a simple water balance equation. It looks like easy on the equation, but it's not very easy to use, trust me. Let me explain that. And this is another paper as for the eastern part of South Dakota and North Dakota as well as Minnesota. A lot of our field, we also have a drainage issue. Our water table, as a one study in North Dakota said, if your water table is 8 feet below surface or within 8 feet from the surface, that water table will still contribute to the crop water consumption. So crop can get the water if the water table is within 8 feet from the surface. So with that, a lot of our field, probably 6 feet below surface or 3 feet below surface, we modify the checkbook methods. We include subsurface drainage, we include surface runoff, deep percolation, and sub-irrigation, which is, we use the term upward flux from there. So we have a publication that you can access. This is a modified, it's Excel version of the software of these methods. So in order to use that, you can do the soil moisture deficiency, get a soil moisture sensor, predict that, what will be the soil moisture for tomorrow, and then, what's happened for today, and then crop water use and rainfall and the net radiation. And of course, based on the water balance, moisture in equals to moisture out, you can slightly modify that to get the moisture for today plus the rainfall plus net irrigation equals to the the soil moisture deficit for tomorrow plus the crop water use for tomorrow. So now I use the different color for the crop use. And that's a trigger part, because rainfall you can measure it, irrigation you can measure it, soil moisture sensor you can also measure it. But what about this crop water use? This crop water use, in another term, we call it crop evapotranspiration. So this is the actual crop evapotranspiration. It depends on the crop type, stage of the development, soil water status. We combine all these three terms into a term called crop coefficient. And then there's the atmosphere conditions, depends on the air temperature, relative humidity, wind speed, and radiation. So we use all those, we calculate the reference ET. And then the actual ET is calculated from the crop coefficient and the reference ET. Well, the crop coefficient you can get from the literature review or from research. Well, the reference ET normally you get from the weather station. So as you can see for the KC, that Dr. I don't have the reference here. This is from the irrigation management paper, Eisenhower paper. Actually, it's a textbook. This is chapter 4. As you can see that the curve changes and also slightly change based on the irrigation status. So that's why if we modify that, we can see that there's three numbers you get to know. One is the initial KC at the starting stage, and the peak KC, and also the KC at the end. And also you can modify that based on the soil wetness. On the right-hand side, there's a table, and I put some red square there, as you can see that, and those for the vegetable crops. Of course, if you have a local measured KC, that would be great. But if you don't, you can still use these. Sometimes we do modify these based on the, the relative humidities and some other parameters. Check this textbook is on the ESB website, chapter 4, it has more information. And so, as I mentioned, that where do you get the weather data if you are in South Dakota? Yes, you get from Mesonaut. Depends on your location, you can get the weather data, you request that. How do you calculate the reference ET? Well, if you're very professional, you can get the paper, do it. But if you just want to do it, you can send an email to, actually now the email is a web form sent to Dr. Rick Allens, and he's a professor at University of Idaho. That there's a reference ET software, so that there's a standardized reference ET calculations, and really depends on what kind of data you have. And sometimes you just have a temperature data, and there are programs to do that. If you have a set of data, it will be like you can use a much better equations. If you're in North Dakota, your life is much easier. Go to this NDON, it provided the reference ET directly for you. And that reference ET, I have a paper on that method, is very accurate, and data quality are also very good. So now enough of the background, so we'll talk about irrigation. So there are subsurface irrigation, yes, you apply water from below ground. And the sub-irrigation can also, like what I use a subsurface drainage system. I have a control structure and back the water to the field using the same drainage system and using gravity. And we also have the subsurface drip irrigation. And on surface irrigation, you can have this surface irrigation like a flat furrow level basin, graded basin. That's the typical. We have some of them in the western part of North Dakota. And also the sprinkler irrigation, especially this center pivot sprinkler irrigation is probably, I would say more than 90% of irrigation in North Dakota is the center pivot irrigation. And I don't know the percentage in South Dakota, it's probably high. And then we also have this trickle macro drip irrigation. And, they are the key for today. Another way to categorize these is called gravitational irrigation, like some of the surface irrigations or sub-irrigation. And then there are pressurized irrigation, such as the sprinkler and the drip irrigation, where sprinkler irrigation is a high pressure, compact irrigation system, where drip irrigation is a lower pressurized irrigation, whether it's a surface or sub-irrigation. When the pressure is different, the energy cost is going to be different. So, and then once you know that what irrigation you want to use, and then there's another message that to you is that whether your field is really suitable for that irrigation. Some of you say, oh, I have money. Yes, but depends on the situation, you may not. So I put 14 items here to give you a idea on what kind of irrigation that's suitable for your field. And more of the information is from that textbook. So let's come back to here that you want to use drip irrigation. You probably use consider the topography. So your field need to be flat. If not flat, drip irrigation may not work. And then you need a high water quality water source. If the water quality is not good, the treatment can be very expensive. And then there's a capital requirement. The cost is higher, and the management scale is also very high. And the good thing is you can apply chemicals and fertilizers or others through the drip irrigation. Of course, there are many other benefits, but these are the keys that I want you to think about when you choose drip irrigation. So now come back to the real part, drip irrigation. So drip irrigation is a method of irrigation that delivers slow, frequent application of water to the soil using a lower pressure distribution system. Usually it delivers the water to individual plants, and the outlet normally placed at a short intervals along the a small plastic tube. It is also called the macro trickle irrigation, bubblers, localized small macro sprinklers, macro splinter, macro sprayer. So it's really the emitters is different, depends on the situations. And so the good part about drip irrigation is a very high efficiency. It probably is the highest. It is the highest efficiency. I would say about 90%. Sometimes for a short field, a small fields could be close to 100% because it only irrigate the soil around the plants. And the deep percolation is eliminated. It's very minimum evaporation because most of the time drip irrigation also work with mulches, whether it's plastic mulch or some other type of mulch. And the cons are that the management requirement for this system is very high because it's irrigate a small amount. So if it is get behind, make any errors, your crop may really suffer from it. So that's why we said there's little room for errors. and there's a high requirement for water quality. It doesn't mean you cannot do it. It just means that it'll be more expensive. You will need more filters. You may need some chemications or some of the acid or pH or EC adjustment before you directly use that water for your irrigation. So these are the different irrigation types in drip irrigation. The first one is probably more common for field crops or for vegetables as a surface drip. There are also macro sprays that's probably used for lawns or for trees or broad, like blueberries, those bushes. There's bubblers, I saw bubblers especially used for trees. It has a much higher flow rate. And then it's a subsurface drip. So basically drip irrigation, but it's buried below surface. Well, when you choose between surface and subsurface drip irrigation, one thing you really have to ask is what kind of crop. If you have a perennial crop, maybe subsurface drip is much better because you can avoid that your drip tubings that be freezed or be like chewed by those small animals. And also if you have higher erosions, very sandy soil, and then subsurface drip probably can avoid this higher evaporation loss. And the other things are listed in this table. And this is typical drip irrigation system. As you can see that you may only use part of that or may use all of them. Yes, you will have emitters that control the water. You may have laterals, but sometimes if you have a small field, you may just have the maze and sub-maze and maze. So that depends on your field layout. And then you will have a water control station. That's definitely. So from your water source, normally, for our situation, need a pump. But for gardeners, you probably just use your domestic water, so you don't need a pump. But you do need valves. You need a filter, a pressure regulator, and pressure gauges. So most of our drips works between 10 to 15 psi. But if you get groundwater, your water can be like 30 or even 100 psi. So if you don't have a pressure regulator, your system will be blow out. So I know a lot of farmers are very handy. You probably can lay out the system on your own. That's fine. I lay out my system on my own. But I would think that you probably want to pay a little bit extra to have someone do the design for your control station, because on the water source pumps, especially you have the fertilizer and chemical injections. All the design need a systematic approach, and let the professional do the professional work, pay a little bit money so that you will have a perfect design that can work for many years. And I know you probably don't trust me, and so this is a filter here and another filter, and then this is a fertilizer injector, another injector, and this is a automatic system. As you can see that I know what they do, but I don't know how exactly they worked because the professional knows. So if most likely for a farm, you will ended up on the right hand corner system like that. So that's why you do need someone to design the control system for you. And then when one thing I always pay attention is water quality, whether it's suitable for drip irrigation or not. That before you even use that water for irrigation, you do a soil test, you do a water testing, find out whether your water is in which class, and whether it's good for irrigation or not. I know North Dakota, we have the soil testing lab and some other labs, they especially do a irrigation suitability testing. Here the pH is 6.5 to 8.4, but I know for Fargo city water, our pH is 9.2. If you always use that water, you may build up the salt, near the surface. And then, there are different treatments and different filters that you can choose for, depends on your water quality. So that you can check this table and find out the details. And then, come to the details. When you choose the drip irrigation, one thing is you have to know your soil. If you have a sandy soil or clay soil, if you have a sandy soil, more gravity, water will move downward much faster than, horizontally. So for a sandy soil, you may use two laterals or two laterals, and you may use one, lateral on the surface, one, below surface, so that it can have a more uniform water distribution for your plants. And some softwares can simulate these distributions for you. And if you don't know all the backgrounds on how water really moves in soil, and I strongly recommend you watch this video. It's about, I think, 24 minutes. For my class, the first class, I always encourage student or require student to watch this video, and they will get so many informations about how water moves in the soil. And then so next part that, you want to do the drip irrigation, your water quality is fine. So you want to do the design. Even you hire a professional, but you still want to do the design or get a scratch paper on your own. So the first thing is do the soil analysis, find out what is the soil type and the texture, water holding capacity, hydraulic conductivity. You can go to the web soil survey to find out if there like a tutorials on how to use web soil survey, find the information. Second is, your topography, topography of the field. If you don't have a GIS background, you can go to LARDA map, download the map directly for your field. You need to know your climate conditions, your rainfall reference ET, and frost days. If you put on the surface, you don't close the system or flush the system before the freeze, the frost happened, and you will know that those pipe, if you still have water there, they can break. Your water cells, identify your water cells, do the water quality analysis. So the second part, your crop, the crop ET or the crop water consumption really depends on the stage, soil type, climate conditions. I already showed you earlier, get a reference ET, get a KC value for your crop. And also you need to know your root depths. Depends on the crop, the root depth is different. And then you want to design your drip irrigation. So there's the drip tubings. The drip tubing you buy could be, a 2-inch space, could be 12-inch space, and the flow rate is different. So when you buy the tubing, there are cheaper ones and more expensive ones. You make sure your tube that you buy can handle the flow rate that you want to handle for, for your field. And the emitters also, they're a function of pressure. And normally when you buy them, it comes with a gallon per minute per 100 feet of drip tubing. And then the filters, pressure regulators, you need those to prevent waterlogging in your pipe, and also a pressure regulators to maintain a consistent water pressure throughout the system, throughout the application. Another thing, if you are experienced farmer, you check your field. I think 2 years ago, we found, our irrigation, they're supposed to be between 10 and 15 PSIs, but then the pressure drops to like a 7 PSIs, and we realized there's probably some leaking problems, and we checked and we didn't find out. Later on, we found actually is one of our filter. The filter has a clear plastic cover, and then the algae is growing there. So we changed to a new filter, and then we put a aluminum foil cover the filter, and then the clogging just eliminated. So there could be a lot of problem, but the pressure is a good indicator whether your system is working or not. So, and then you had to, the next step is lay out your irrigation. It's a spacing. So it decide, on the number of drip lines needed and the space between the emitters. As I mentioned, it could be 2-inch, could be 6-inch and 12-inch. Normally, if you go to the drip irrigation system supplies, and they will ask you, if you have this crop, you need this space. There are some general guidelines, and then you can put a single line or dual line or even more line, depends on the soil and the crop, because your goal is to ensure a even water distribution for your root zone for that crop. And the maize and sub-maize lines, you want to design the layout so that they can deliver the water efficiently. Again, the same principle, you want to use less of the maize and sub-maize because they cost much higher than the laterals. And then the design, the installation guidelines, with the surface installation, normally you will have a mulch, or you can do a shallow barrier, because that will be more efficient. And after the installation, you want to test the system for leaks. And sometimes you will test, most of the time you will test it several times. Normally for our field work, we'll probably test it for a week, because right after installation, if you tie the end, you don't see the problem, but after, a day or two, you will see the problems. So you can also have more of the pressure regulators or pressure gauges put at the beginning, at the end, see the pressure it's evenly, distributed. Because I know when we do research, we will test the drip tubings, test the pressure and also the flow rate along the drip lines. But as a farmer, maybe put a pressure regulator at the end, periodically just see whether your water is distributed evenly. And then the next part after you install it is the management and the maintenance. Yes, you work on the irrigation scheduling. You can base on soil moisture, based on weather data, or based on the stage of the crop. You need to adjust as needed, because you know that the crop coefficient, let's say, is just for, let's say for watermelon. Like last year, I grew 4 varieties of watermelons. Each one of them, the yield is different, and theoretically, the ET is going to be different, and the Cassie is different. So that's why you get to adjust based on your crop. And you had to do a regular maintenance of your system, such as for the filters need to be cleaned, check for leaks and damage, and flush the system periodically and prevent a clogging. Especially like a calcium carbonate can be clogged, depends on your water. And then you want to do the monitoring and adjustment periodically, make sure that they are working. It seems a lot of things, but Here is a table to show you that, something you do once a year, something you will do probably every cycle, irrigation cycle. You may use some of them may not be really applicable to your situation. So come to the trigger part. I know after I talk about all these things, if you are the farmer who hasn't applied irrigation, your first thinking is it's too much work. I'm not going to do it. Well, this slide will really show you that engineers can make your life much easier. So how to manage your drip irrigation? Yes, you can do the traditional way, turn on and off the irrigation manually every day when it's not rained, once it needed. Maybe sometimes you have to turn it 3 times per day because that's what your crop really need. Oh, you can set up a timer, turn it on and off irrigation at a fixed time. I'll just irrigate 1 time per day, or irrigate once for every 3 days. And you can also base on water balance, like the checkbook methods. If you have some automatic device, you can use some other controllers, control the irrigation based on the crop, based on the soil, or based on the weather conditions automatically. So it uses the real world data to do the control. You can also manage that remotely with your phone. So we call that smart water management. So for this smart water management, yes, got to be automatic. If it's not automatic, it's not smart. Yes, it will use sensors, whether it's a soil moisture sensor or crop stress sensor. It can be remotely controlled. It's give a precise, very high efficiency of water management, and also have a flexible scheduling because it depends on the soil moisture status. So you can irrigate once per day, or irrigate 6 times per day, or even 12 per day, depends on the status or the threshold that you set up. And it's a labor and cost saving. And also the entire thing doesn't cost a lot of money. The thing we use costs about $280. So, with the irrigation that you already installed, the additional control system costs you $280. I know the price may change already, but that's what we used 2 years ago. So how that really works? See, I have a field. I have a watermelon, winter squash, and muskmelon. And then I will put a soil moisture sensor in the field. And I connect that sensor with a controller with the soil moisture status I already set up. Remember, there's a management allowable deficiency. So I set up a 10% MID and 30% MID and 60% MID. So, the management is different. And then I put a timer here, if a 10% MID, probably each time irrigate 10 minutes, but, each time the very, wet range is my threshold. And then I contact the timer with a solenoid valve. Of course, beyond that solenoid valve is your irrigation control system. It has, the pump, the filters, the water source. So I manage everything with my phone, and also have a web camera monitor the entire field. And we use this system in high turnover. As you can see that we have green peppers and tomatoes. We also that use in the field with watermelon and muskmelon, winter squash. I know I want to stop here, and below is a drip irrigation design examples, but I will share the slides with you, but I don't think we have a time for that. So I will stop here and let you ask any questions that you may have. Any questions?
I'm not seeing any questions yet in the chat or in the email, so.
Okay. Do you have any questions? Can be anything that's general. Yeah, we I think on the North Central Region Water Network, I gave a talk probably last year, especially talk about how this smart irrigation really worked. And also July 30th, I believe, NDSU have a workshop on high turnover irrigation, no, high turnover crops, and I will have probably a specialty talk on smart irrigation on how that works. I will send you a link. So for anyone want to learn more about the smart irrigation, how that really works, I will be happy to share more information about that, how that system really works. But because today's title is really on drip irrigation, so I talk about the basic principles about drip irrigation.
Yes, I would love to share that link.
Yeah,
with
once I
our,
get that, I can send you an email and share with
okay,
others.
absolutely.
Yeah. Okay. Well, since we have more time, do you want me to go over the drip irrigation design example
Sure, we still have 10 minutes. If you have time, that would be wonderful.
Oh, okay. All right. So this is the actual credit for those who want to do the irrigation design. If you're not interested, you can stop here. So this is a class example from my colleague, Dean Steele, in ABAM 464. This is the soil water conservation engineers. So for this example, so we have drip tape is a 4 feet, space between the crop rows, and they want to irrigate the winter squash. And the field is 500 feet long, 144 feet wide, with 1% slope along its length, kind of run downhills. So, and then there's a submersible pump. It can produce 35 gallon per minute at 35 psi pressure of water. The efficiency from the well is about 70%. So this is not the drip, okay? This is the efficiency of the pump. And the well is located about 30 feet, below. 30 feet at the top of the field. So the soil is sandy loam soil. The field is located in oaks. So we want you to find out what kind of drip tape and the length of the drip that's needed for this field, and the number of irrigation zones, because your flow rate is fixed. If the flow rate is not enough to irrigate the entire field, you had to put your field to be in different zones so that each time you irrigate only one zone. And also the irrigation time for each zone that will meet the peak water requirements. And so this is really a sketch of how the field will really look like. The maize on the north side of the field. So we will assume that the pump pressure is adequate because regulators at each subheader are set at 10 psi. It could be different, depends on your laterals. And each zone will be irrigated, every day. And the peak ET is about 0.3 inch per day. So that's why we want to calculate the number of tapes, that's irrigation tapes that's going to be used. So the field width is 144, and then the rows for the crops are 4 feet per line. So that's why we need 36 lines. And then so the total length will be 36 lines. Remember the length of the field is 500 feet. So we will need 18,000 feet of total length of tape, because when you buy the drip tape, they come as like a 5,000 feet per row or 6,000 feet per row. And that way you will know how many tapes you will need. So assume the flow rate is 0.5 gallon per minute per 100 feet. It could be different, but let's just use that. And the emitter space is 12-inch emitter space. And you know, depends on your crop, we choose the 12-inch ones. And so then your flow rate per tape is going to be 0.5 gallon per minute per 100 feet. And we have 500 feet per length. That's the length of the field. We got 2.5 gallon per minute per line. And then we will have 36 lines. So then we will have 90 gallon per minute flow rate. So remember, what is the flow rate we have there on the given condition? It's a 35 gallon per minute. So that means we had to divide our field to do different zones. So probably two, you know, two different zones. Let's see. So the number of zones, 95 divided by 35, 2.6. So we round up to 3 zones. And then we have 36 lines divided by 3 zones, so 12 lines per zone. So that means you will put a sub-laterals for every 12 lines. And so the area within each of these sub-zones, each zones is about 24,000 square feet. And then based on that, the amount of water, remember the 0.3 inch per day is a peak ET. And this ET is actual ET. You don't work with the KC or reference ET part. And this is just for the design purpose. And so from there, we estimate that 4,488 gallons is needed. And then remember that 2.5 gallon per minute per line. And so we have these 12 lines. We will need about 30 gallon per minute per zone. And so this 30 gallon per minute per zone is less than the 35 gallon per zone. So the zone size and the tip flow rate are acceptable. So our design with 3 zones are fine with this type of tape. And then, you know, the time that's needed for irrigation for each zone. And we calculate, we know the flow rate is 4,488 gallons per zone. And with 30 gallon per minute, it will be 149.6 minutes. And that is about 2.5 hours per zone. And so, and then, you know, we have 3 zones, and of course, we don't irrigate them at the same time. So we have 24 hours, and we probably some zone want to irrigate in the early morning and late afternoon. You know, we just separate the zones. And then the volume of water that's needed per day is 13,464 gallons. So these are, you know, the calculations. We get the zones, we get the volume, we get the time. And so there are some other questions that's asked. You know, if we irrigate like 2.5 hours per day, it could be in one continuous set. Oh, maybe we can split them to, you know, several shorter intervals. Each time we irrigate 1 hour, but, you know, put them in different, you know, different zones. We can use the solenoid valve to make the water distribution to each zones automatically. And then we can use a controller to start and stop the pump, control the valves automatically. And there are battery-based controllers that are very cheap. And then you can use a flow meter to monitor the system. And also you need to have the filtrations or backflow prevention devices to make sure that your system works perfectly for this setup. And also you need to test the water quality, where high pH, a higher bicarbonate can be very damage to your system. And drain properly, and before the winter really starts. And so these are some of the questions and want to ask you. So I'm going to finish here. Okay, I stopped.
Thank you very much for all that information, Doctor.
Yeah.
I will certainly, if you want to email me that link for that class coming up, I will certainly get that out.
Yeah, and also, people watch the webinar, they may have questions regarding some of the slides. You can generate those questions and send to me. And I really, I talked as if I teach a class, so I don't really know the feedback, but I welcome any comments from the audience or from the people who watch the webinar.
Nice.
Yeah.
Feel free to email me those questions, audience, at sdspa.urbanag@gmail.com. Again, thank you, Doctor. We appreciate your time and knowledge of the subject of drip irrigation. This webinar was funded through the Conservation Collaboration Agreement between NRCS and South Dakota Specialty Producers Association, NR 226740XXXXC008, to promote sustainable agriculture practices and environmental stewardship. Its contents are solely the responsibility of the authors and do not necessarily reflect the views of the USDA or the NRCS. Again, my name is Melissa Niles. I am the Urban Ag for South Dakota Specialty Producers. Please visit us at SDSPA.org to view our upcoming events, find producers, and become a member. Thank you, Doctor.
Thank you.